In the previous classes, we have seen how to construct various kind of asynchronous counters. So those counters can be up counters or down counters or a kind of a circuit which can provide either up or down counters. And also we have seen the another kind of counter with an example. It is a random counter also, right? Yes. Now in today's class, we'll start with other type of counters. They are synchronous counters. So guys, the main difference between asynchronous counters and synchronous counters are, so in synchronous counters, the same clock pulse is going to be applied to all kind of flip-flops, right? If you remember the earlier classes videos, the difference between the synchronous and asynchronous counters, you can able to clearly observe. If I am going to take any kind of up counters or any kind of a down counters, if I am going to have multiple flip-flops, if all the flip-flops are going to have same kind of clock signal at the same instance of time, then I can call it as synchronous counters, right? So that depends on that varies from any kind of a clock. Clock can be a kind of positive triggered or negative triggered, whatever it may be. If the clock you are going to apply it for all kind of flip-flops at the same instance, we can call it as synchronous counters. Whereas coming to asynchronous counters, the clock is going to vary from one flip-flop to another flip-flop. In other words, if I say, if I am going to give clock to the first flip-flop, the second flip-flop clock will be get from the first flip-flop output. Similarly, third flip-flop, you will get the clock from the second flip-flop. Okay, so this is the main difference between synchronous counters and asynchronous counters, right? And the remaining things all are going to be similar, right? If you are able to observe, the synchronous counters also contains as earlier discussion, it can be kind of synchronous up counters, synchronous down counters, synchronous up or down counters, and in addition to this, we are going to have some other kind of counters are there. We can say that basically shift counters, shift registers or shift counters. We'll discuss at the end of this kind of counters, right? Shift counters can be kind of again a ring counter, and another type is a kind of Johnson counter. These are very important and very easy also, right? Now in this class we'll try to construct one kind of up counter, that is synchronous up counter, right? So basically if you'd like to construct any kind of 2-bit synchronous counter, what is the meaning of this one? Here we are going to have 2 bits as values, and you are going to get how many number of states you are going to get, right? So basically, if you remember the earlier videos, if you are going to have 2-bit asynchronous up counter, meaning that how many flip-flops you are going to need? You need 2 flip-flops. If I am going to have 2 flip-flops, you are going to have 4 possible values, right? 0 0 0 1 1 0 1 1, right? I can call simply as mod 4 counter. Similarly, here also, if you are going to construct any kind of a 2-bit synchronous up counter, you require to have 2 flip-flops. Okay guys, so basically if you are going to have 2 flip-flops, again you are going to get 4 states, that's for sure. You are going to get 4 states, good, right? But as I said, while discussing the difference between synchronous counters and asynchronous counters are somewhat difficult implementation compared to asynchronous counters. So if you try to construct any kind of a synchronous counters, so it's better to follow some kind of procedure, right? So the basic procedure what you have to follow while constructing the synchronous counters is, first you have to identify what type of flip-flops we are trying to use, right? For example, you can understood that you can able to implement any kind of counters with the help of either T flip-flop or D flip-flop or JK flip-flop or whatever flip-flop it might be. You can able to implement, right? So if you would like to, if you are interested to construct any kind of a counter, you first decide what kind of flip-flop you are trying to use. What kind of flip-flop you require to construct your respective counters. And the next step is you try to draw the excitation table for the corresponding flip-flop, right? So if you are trying to think that it is a kind of a JK flip-flop you are trying to use, you need to know the excitation for the JK flip-flop, and then you have to write down the state diagram for the respective requirement, and also you can able to construct the excitation table for the circuit diagram, circuit excitation table. Then from this you can able to simplify it, and you can able to get the expressions by using K-maps. And in step Y you have to write down the logic diagram. These are the 5 steps that you have to follow while trying to construct any kind of synchronous counters. Okay. So guys, if you try to think which one is going to be more fast and which one is going to be slow in execution, can you tell which one? Right, so we'll try to discuss this thing in the next video construction. Let us try to do like which one is the best one, right? Is the synchronous counter is fast or asynchronous counters is fast, right? Of course asynchronous counters are slow in execution. Why? The point is, if I want to execute the flip-flop 3, this flip-flop 3, it has to depend on flip-flop 2, right? Yes, if it wants to execute, it has to depend on flip-flop 1, right? So as there is a dependency among each other, so to execute the last one, it has to depend on all the remaining things. So that's the reason it is going to be very slow. Whereas coming to synchronous counters, it is going to be execute fast because there is no dependency. But the point is, whenever you are trying to execute any kind of synchronous counters or asynchronous counters, there must and should have some kind of combination circuits we are trying to use, right? If you remember, you are trying to use some kind of combination circuit. This circuit input you are going to be used as preset or clear kind of things you are going to use. Similarly, in synchronous counters also, to make it activate one flip-flop with another flip-flop, we are going to use some kind of combination circuits wherever it is necessary. So if you would like to define the propagation delay of the synchronous counters, if I say TPD synchronous counters, it can be time taken for the flip-flop plus time taken for the combinational circuit. Right? So meaning that if I say something as the total propagation delay, what it is going to take, it will be represented in the form of propagation delay of the synchronous flip-flop equal to synchronous counters equal to propagation delay of the T flip-flop plus time taken for the flip-flop plus time taken for the combinational circuit, right? If I try to say this in terms of clocks, right? So I can generally write time taken for the clock should be greater than or equal to time taken for the propagation delay, right? Yes. So what is the general meaning of this one, right? So the general meaning what you can understood is, if you would like to give one input, that has to be processed, and the next clock you have to give should be greater than or equal to propagation delay of the synchronous counters, meaning that the next clock signal has to be given, or next clock signal time should be given after time taking for the propagation delay. After time taken for the propagation delay. That is the meaning of this one. Right. Similarly, if you take the asynchronous counters, time taken for the propagation delay of asynchronous counters equal to, see guys, here if I would like to define this flip-flop 3, it is going to depend upon all the n flip-flops time, so that's the reason n into time taken for all the flip-flops plus time taken for the combinational circuit. Am I right or not? So for everything, it has to be one kind of combinational circuit. Yes, that's the reason I have written like this. Similarly, here also you can say that the next clock signal you have to give after the propagation delay of the asynchronous propagation delay, right? Then it will be works perfectly fine, right? Yes. So this is for this class. We'll discuss the remaining things in the next class, right? So but for the time being, try to remember the procedure for to construct any kind of synchronous counters is you have to follow these 5 steps, right? Yes. Thank you.